Boys and girls, this is Mr. Minis here. Welcome to this video for the Chapter 4 test review. Glad you're here. My disclaimer as always, do not come and watch these videos and just copy down the answers. Need you guys to work through these problems on your own and then come watch the video and make sure that you're correct or iron out any misunderstandings that you might possibly have. So, keeping with the tradition of showing you guys something awesome, this is a GIF of Clemson's quarterback from last year, Deshaun Watson, the MVP of the national championship team, taking a little bow there after scoring a touchdown against Notre Dame in Death Valley. All right, so let's jump right in here with our test review. Number one says points D, E, and F are midpoints. So these three guys are midpoints of my triangle, so I can put some ticks on my diagram. That means that side's cut in half. Double ticks on AD and DC, double ticks on CE and EB. And it's saying if DE has a length of 12, so let's label that, that guy's 12, and DF is a length of 13, I'll put a 13 right there, and it tells us that AC has a length of 28, so this whole thing, that whole length right there is 28, okay? And then it's saying, what are the lengths of AB, CE, and EF? So let's take these one at a time. AB is this whole length here. Okay, this is the base, so on my mid-segment theorem tells me that the mid-segment is half of the base. So if this mid-segment, DE, is 12, then I'm just going to double that. So that means that AB is 24. So line segment AB is 24. And then let's take CE. Okay, CE is this guy right here. CE. Okay. Well, I'm looking at this mid-segment. These guys are parallel. The mid-segment is parallel to the base. So if DF is 13, then I have to double that to get this whole length. So if I double that, that means that CB, this whole length is 26. But that's not what they asked for. They asked for CE. Well, each of these guys is split, right? I got double ticks here and double ticks here. So CE and EB are the same length, and if the whole thing is 26, then each of these guys also have to be 13. So EB and CE are both 13. And think about it this way. It takes two of the mid-segments to equal the base. That's why it's half of the base. So if the mid-segment is 13, each of those pieces are also 13. Excuse me. And the last one, EF. Okay, so EF is this guy right here. That's the mid-segment. And again, I'm looking at the whole base. This whole base is 28. So if I divide that by 2, then my mid-segment is going to be 14. So CE, we said that piece was 13, and then the mid-segment FE, that's half of the base. Half of 28 is 14. Okay, number 2 is another mid-segment problem. How do I know I have a mid-segment? Well, if I have a line that goes straight across in my triangle, that ought to be a red flag. Hey, maybe this is a mid-segment. But I'm also looking at these numbers. All right, 8 and 8, so that means I can put a tick there and put a tick there. Then I have 9 and 9. That means double ticks there and double ticks there. So this is what we're, if I turn my paper, this is what we're used to seeing. I've got a mid-segment, and then these sides are the same, and then these pieces of that side are the same. And it's asking what is the value of x. And the mid-segment is half of the base. So if the base is 6, 6 divided by 2 is equal to 1004.2. Just kidding. Half of the base, 3. X is equal to 3. Okay. Next one, what is the length of the mid-segment? How do I know I have a mid-segment? I got 24 and 24. I got 31 and 31, double ticks, double ticks. All right, now when they throw algebra at you, you've got to remember that it takes 2 of the mid-segments to equal the base. So you do not set these equal to each other. I've got to double that expression, okay? The 5x plus 2, it takes 2 of those to equal the base. So I'm going to do 2 times the 5x plus 2. And then I'm going to set that equal to the base, the 3x plus 32. Okay. Let's zoom in just a little bit. Okay. All right, so now I'm going to solve this equation. Use the distributive property, 10x plus 4. Don't forget to double the 2 as well, and then set that equal to the base. I want a positive variable, so I'm going to subtract 3x from both sides. That leaves me with 7x plus 4 is equal to 32. Subtract 4. 7x is equal to 28 divided by 7. and x is equal to 4. Now remember, you've got to pay attention. Is that what they asked? Please don't miss these free points on the test because you know how to work the problem, but you didn't read it. They're actually asking for the length of the mid-segment. So I got to take this 4 and plug it right in there for x. Okay. This one, it does matter which one you plug it into because these guys are not the same length. If I plug it in there for x, I'll get 5 times my x, which is 4, plus 2. That's 20 plus 2. That's a length of 22. Okay, so the mid-segment length is 22. Take a few extra seconds and plug it back into the other one just to make sure you didn't make a mistake. If I plug in the 4 here, let's plug it into the other one. 3 times 4 is 12. 12 plus 32 is equal to 44. Is 22 half of 44? Yes, it is. So take a few extra seconds and just check your work. All right, number 4, what are the measures of angles A and B? All right, this is all mid-segment theorem stuff, guys. So the mid-segment is telling me that the mid-segment is parallel to the base. Okay, when you got parallel lines, all the stuff from chapter 2 comes back into play. Alternate interior angles, same side interior, corresponding angles. All right, if I extend these lines out, here's my transversal. Okay, A is in the top right of my box, 80 is in the top right of my box. These are corresponding angles. So A is also 80 degrees. All right, and then look at B. Okay, B is inside and 50 is inside. Okay, so these are not corresponding angles. Remember the little trick that I taught you: when lines are parallel, all the big ones are the same, all the little ones are the same, one big and one little add up to 180. B is actually big, 50 is actually little. These are same side interior angles, so I got to do 180 minus 50, and then B is going to be equal to 130 degrees. Okay. Corresponding angles, same spot in the window. These are same side interior angles. They have to be add up to 180. They're supplementary. Okay, number 5. If CD is a perpendicular bisector of line AB, write down everything that you know to be true. Okay, CD is the perpendicular, and it's a bisector of AB. Okay, so whatever line comes after the word of, that's the one that's being bisected. CD is the bisector of AB. So that means I'm cutting AB in half. So I can put ticks there. So I know, one of the things that I know is that AO, line AO, is equal to line OB. Okay? Because it's a I'll just put in parentheses, I'll put it's a bisector. So I'm cutting AB in half. Okay, what else do I know? Perpendicular, that's a box, 90-degree angle. So I can say angle COB is equal to 90 degrees because it's a perpendicular bisector. Okay, now the important part. What does our theorem say about a perpendicular bisector? Our theorem says I can pick any spot on the perpendicular bisector and that will be equidistant from the endpoints of the line. So that means I can put double ticks there and there. If I pick a spot down here, those distances up there, triple ticks there and there. Okay. So the other thing that I can say is that any point on the perpendicular bisector, any point on the perpendicular bisector is I know you guys love that word, equidistant. That means equidistant from the endpoints of the line. Okay, any spot on this perpendicular bisector will make an isosceles triangle with the endpoints of the line. Okay, number 6, find the length of BC. Okay, where's BC? Here's this guy right here. I want to find that length. Okay, well, what theorem applies to this diagram? Well, I see some arcs right there and right there. So these angles are the same. We don't know what the angles are, but I know they're the same. This is my angle bisector. This is the Spider-Man theorem, right? Spider-Man. Any spot on this angle bisector is going to be equidistant from the sides of the angle. This is spiderweb, Spider-Man. That means these two distances have to be the same. So I'm going to take these two expressions and set them equal to each other. Most of the stuff in this chapter, guys, the algebra problems and expressions, you're just setting them equal to each other and solving, except for the mid-segment. That's the only one. You've got to double the mid-segment and set it equal to the base on the mid-segment problems. Everything else we're going to be setting equal to each other. Subtract 3 from both sides. 2x is equal to 4. So x is 2. Now, when I get done, what have I been asked to find? Did they ask me to find x, or did they ask me to find something else? They want the length of BC. So I've got to take this guy and plug him back in. Now this one doesn't matter which one you plug it into because both of these lengths are the same. So it doesn't matter if I plug it in here or here. Let's plug it into both. 3 times 2 is 6. 6 plus 3 is 9. So we're going to say BC is a length of 9. All right, let's plug it into the other one. What is 2 plus 7? It's also 9. Okay, so just take those few extra seconds and double check your work. Number 7, if BC equals CD, okay, so if we got BC and CD are the same length, what is the measure of CAD? What is the measure of that angle right there? Okay, this is also the angle bisector theorem because since you tell me these distances are the same, making right angles with the sides of the ray, I know that I must be sitting on the angle bisector. Okay, that means these two angles have to be the same. So once again, we're going to take our two expressions and we're going to set them equal to each other. Okay, let's get a positive variable. So I'm going to subtract 3x. 2x equals 12. So x equals 6. Now, is that what they asked us for? No. They asked us for the measure of the angle. All right, so CAD. So I just need to plug it into one of these because they're the same. 5 times 6 is 30. So the measure of angle CAD. D, not B. D. CAD is equal to 30 degrees. Let's plug it in the other one. 3 times 6 is 18. 18 plus 12 is also 30. So check your work. Okay, let's on over to the back side of the first page. List everything that we know about the following points of concurrency, the centers of our triangles. All right, the first one is circumcenter. Okay, so let's list out our little mnemonic device real quick. All of my children are bringing in peanut butter cookies, which makes me very happy. Okay, I could change that to students. If you guys want to bring in some peanut butter cookies, I'll eat them as well. All of AO. Altitudes intersect at the orthocenter for O. My children, MC. M for medians, intersect at the C centroid. R bringing in AB angle bisectors, intersect at the I incenter. Peanut butter cookies. PB. Perpendicular bisectors intersect at the circumcenter. If you can't remember the difference between the C for centroid and the C for circumcenter, my children is shorter than peanut butter cookies. So centroid, that word, is spelled with fewer letters than circumcenter. Okay, so what do we know about the circumcenter? All right, so we just said one thing we know is the intersection of the perpendicular bisectors. Peanut butter cookies. Okay. What else do we know about the circumcenter? Okay, this is my cell phone tower. C for circumcenter, C for cell phone tower. I want to stick my cell phone tower right in the middle of the 3 populated areas that I'm trying to get maximum coverage to my clients and my customers. Okay, so the circumcenter is equidistant from the vertices from the 3 corners of my triangles. Evans, Martinez, Grovetown. I want that cell phone right in the middle. Okay, so I can say the circumcenter is equidistant from the vertices, the corners of the triangle. The other thing I can say about the circumcenter, circum means around, circle. The other thing I can say is if I take a compass and put my needle right here at the circumcenter, I could draw a perfect circle all the way around the 3 corners of the triangle. So I can also say circumscribe a circle around the triangle. All right, next one. Point I is the incenter. Okay, AB are bringing in angle bisectors incenter. So I can say this is the intersection of the angle bisectors. Okay, what else do we know? What's important about this spot? This one is similar to the circumcenter, but instead of being equidistant from the three corners of the triangle, this one is equidistant from the sides of the triangle as long as that forms a 90-degree angle. Okay, so all three of those distances are the same. Tick, tick, tick. All right, so I'll say equidistant from the sides of the triangle. And I'll put in parentheses 90 degrees. It's got to be forming a 90-degree right angle. And then also in center, now here is just like the circumcenter, we circumscribed a circle around. The in center, I can inscribe a triangle inside, inscribe a circle inside the triangle. So I will say inscribe a circle inside the triangle. Okay, last one here, centroid. Okay, so G is the centroid. Hopefully this will focus here in just a second. Maybe. Hello, focus. Hopefully I'll get back in focus here in just a second. All right, centroid. My children. M, my children. Medians. C for centroid. All right, so this is the intersection of the medians. Intersection of the medians. All right, what else do we know about the centroid? Okay, the one thing we said is that this is the center of gravity, or balancing spot. I'll just put balancing / center of gravity. We did the little pencil thing, the little glass and straw. I don't know why this is not focusing in correctly. Houston, we have a problem. Okay, so anyway, this is the balancing center of gravity spot on my triangle. The other thing that we said about the median is this little piece, the short piece, is 1/3 of the whole length. So I'll just write short side equals 1/3 of the whole piece, or the whole length. The other thing I can say is that the long piece, that piece is double the short side. So I can say long side is equal to 2 times the short side. Okay. My camera's not focusing in correctly. Sorry about that, guys. I don't know why it's not focusing. It's the first time I've ever had this problem. All right, maybe just have to bear with me here. So number 9 says point V is the centroid of triangle PQR. Okay. Hey, welcome back, webcam. It's good to see you. That's kind of weird. All right, so it's telling me that V is the centroid of the triangle. That means it's the intersection of the medians. And it's saying PV, so this length right here is 12. Now, is that the long piece or the short piece? With the centroids, guys, it's going to be clearly obvious which one the long piece and which one the short piece is. I know we say put your eyeballs in the trash can, but this is one time where one side is clearly longer than the other. It's asking for VT. Okay, so remember, one thing we just wrote up here is that the long side is twice the short side. So if that's 12, then the short piece has to be half of that. Okay, so I can say VT is equal to 6. And then it says if SR, if the whole length is 18, what is SV and what is VR? Okay, so the whole thing, this whole guy is 18. That means I just divide by 3, because remember we said the short side is a 1/3 of the whole piece. So if I divide 18 by 3, then the short piece is going to be 1/3 of 18, which is 6. And then if this short side is 6, then I just double it to get the long side. So if this is 6, then that whole piece is 12. I mean, excuse me, the long piece is 12. So VR would be 12. Okay. All right, number 10, what are the names of segments RT, PS, and QU? RT, this guy right here. So the only thing that I see with RT, the only thing I see is a box. I don't have any ticks, okay? So if I see just a box, that's going to be the altitude. It starts from the vertex and goes to the opposite side, forming a 90-degree angle. PS, I don't see a box. I have no box right here. All I see on the opposite side is I see ticks. So if all you see are ticks, then that is a median. If you see a box and ticks, that's the perpendicular bisector. Okay. QU is an angle bisector because I see these little arcs right here. If I see arcs on the angle, then that's just an angle bisector. So make sure you guys are fully comfortable with these vocabulary terms for the test. Number 11, which angle is the largest? This was our exterior angle inequality theorem that says we learned a couple of chapters ago that the exterior angle is equal to the sum of 2 and 3. So if 1 equals 2 plus 3, doesn't 1 have to be bigger than 2 and 3? It's got to be. When you add two things together, the sum has to be greater than the two individual parts if you're dealing with two positive numbers. So angle 1 is the largest. Okay, number 12 and 13, this is the winner-loser stuff, using my silly little analogy when I put stuff in order. So I've got 40, 60, and 80. 40 is my loser. So the opposite side, AB, this guy is going to be the loser. 80 is my biggest angle, so he's going to be the winner, which means his opposite side, BC, is going to be the winner. So when I put these in order from smallest to largest, I'm going loser, medium, and then winner. So the loser side, AB, all right, so AB is the smallest. Then the middle is going to be AC, that's the middle guy. And then the winner, the bigger side, which is BC. And that's in order from smallest to largest. All right, excuse me. For the angles, it's the same thing, which is just in reverse. I've got 2, 3, and 4. So 2 is my loser. So the angle across from that guy is going to be the loser. So this angle is the loser. 4 is my winner. So the angle across from that guy is going to be the winner. So now, again, they want us to put in order from smallest to largest. So the smallest angle is the loser. Okay, so angle C is the loser. Then the medium angle, which we haven't labeled, is going to be A. And then the winning angle, right here, winner, is angle B. So in order from smallest to largest goes angle C, then angle A, then angle B. Okay, let's move to the second page. Second page. Okay, so the first one that we have up to bat is trying to figure out whether or not I can make a triangle. And remember what we said about trying to make a triangle is if I'm trying to form a triangle here, 2 of the legs have to be greater than the third leg. Okay, we got the whole dinosaur trying to clap his hands, right? You kind of laughed about that in class. I can't even touch, right? So any 2 sides have to be greater than the third. And the little trick that I taught you guys is all you have to do is add the smaller numbers together to find the 2 smallest ones and see if that's bigger than the third. You don't need to go through all 3 combinations. If the 2 smaller sides are greater than, they can't be equal. If they're greater than the third side, then yes, I can form a triangle. So the first one here, I'm looking at the 2 smaller numbers, 4 and 6. Is 4 plus 6, is that greater than 7? Yes, it is. 10 is greater than 7. So yes, I can make a triangle out of that. 2 smallest sides are 12 and 10. Is 12 plus 10, is that greater than the third side, 13? Yep, 22 is bigger than 13, so I can make a triangle out of that. 2 shorter sides, 9 plus 11. Is 9 plus 11, is that greater than 20? And the answer is no, it's not. Okay, these 2 are, but 20 equals 20. I can't make a triangle out of that because I got a line laid on top of a line. They have to be greater than. This would have to be, if it were 20.1, then yes, I can make a triangle. But 20 equals 20, that doesn't work. 2 shorter sides, 1 and 2. Is 1 plus 2, is that greater than 4? 1 plus 2, that's 3. 3 is not greater than 4. Okay, if you that's funny, I don't care who you are. All right, so let's move on. Use the hinge theorem to write an inequality relating line AD to line DC. This is also the winner and the loser, okay? So my loser is the 49 degrees, and 61 is my winner, because 61 is greater than 49. So 49, the loser, that opposite side, AD, that's going to be the loser. The winner, the side across from it, the winning angle is going to be across from the winning side. So that means that DC, line DC, is longer than the loser, line AD. Or you could write AD, or you could write AD. You could write AD is less than DC. Either one of those inequalities is perfectly fine. All right, 15. Two sides of a triangle have lengths of 12 and 16. Fill in the inequality for the possible range. Okay, the range of values. All right, so if you remember the little trick that I taught you, all you have to do with these two lengths is add them together to get the high end of the range. 12 plus 16 is 28. And then all you do is just subtract the two numbers to get the low end of the range. So we have 28 and 4. So that means x has got to be bigger than 4, and x has got to be less than 28. Okay, think about it. Check your work. Let's say that we're saying x has got to be less than 28. What if x were 30? Does 12 plus 16, is that greater than 30? No, it's not. So 30 can't. That's too high. Okay, so that's how we get the 28 range. On the flip side, what if the third side were 2? Take the two smaller numbers. Is 2 plus 12, is that greater than 16? No, it's not. That's only 14. So that's how we get the low end of the range. The shortcut I need you guys to remember is just add the numbers to get the high end, subtract the numbers to get the low end of the range. All right, number 16, this is a little bit trickier. This is probably the hardest thing we do in chapter 4. What are the possible range, the ranges for the values of x? All right, so here's where, again, we got to figure out the winner and the loser. 9 is bigger than 8, so 9 is my winner. 8 is the loser. So that means the opposite angle, this guy is the winner. 35 is going to be larger. I don't know what that expression is. I don't know what x is. I just know that he's the loser. Okay, so that means that whatever x is, this angle cannot be greater than 35 because this side is longer. He's the winner. So I'll set up one inequality to say this expression, 2x plus 3, has got to be less than 35 because 35 is the winner. So I'll subtract 3 from both sides. 2x is less than 32, divide by 2. And I get x is less than 16. Okay. All right, so now we also know that this angle has to be greater than what? It's got to be greater than 0 because I can't have a negative angle. So I'm going to set up another expression that says, I don't know what this is, but I know that that expression, when the dust settles, has got to be greater than 0, so I don't have a negative angle. And then I'll solve this inequality. 2x is greater than negative 3, divided by 2. Yeah, don't be scared by decimals. X is greater than negative 3 halves or negative 1.5. Doesn't really matter how you leave that. So my final answer is x has got to be less than 16, and x has got to be greater than negative 1.5. That's your final answer. I'll say this again. I showed you guys this in class, but if anybody's watching this video that I haven't taught before, when you're trying to figure out which inequality sign to use, this is real easy. Some of you guys were probably taught alligator or Pac-Man or something. This is how I do it. 2 dots is more than 1 dot. Okay, so that tells you which way this thing opens. 2 dots is more than 1 dot. Okay, number 17 is exactly like 16. We're just going to set up 2 different inequalities. Who's my winner and my loser? 6 is greater than 4. So 6 is my winner. And I would suggest you guys label this on your test. 4 is my loser, just to make sure you don't get mixed up. Okay, so which angle is the winner? 43 is the winner. Because 6 is longer than 4, that means this expression right here, whatever it is the loser. So I know that this expression, the 4y minus 5, cannot be greater than 43 because he's the winner. So our first inequality says 4y minus 5 is less than 35. I'll add 5. 4y is less than 40. Oh, I'm sorry. I'm looking back at the wrong problem. Y'all probably yelling at the computer screen there. Yeah, 43. Probably helps if you look at the right problem, I think. All right, so if I add 5, I get 48, and I'm going to divide by 4. Y's got to be less than 12. Okay, the second expression, inequality I need to set up is that this angle's got to be greater than 0. So 4y minus 5 is greater than 0. Add 5. 4y is greater than 5. Let's divide both sides by 4. And once again, we get these lovely decimals. Again, you could leave it as a fraction if you wanted to. So I know that x has got to be less than 12. And x has got to be greater than 1.5, so I avoid having a negative angle. So that is my final inequality. Feel free to rewind the video on these two problems if you can get that the first time. This is probably the most difficult stuff of the chapter. Match the correct point of concurrency with segments. All of my children are bringing in. Are bringing in. Angle bisector goes to the incenter. All of. Altitudes of for orthocenter. My children. Medians. Centroid. Remember, centroid is shorter than circumcenter, so my children is shorter than peanut, butter, cookies, circumcenter. Okay, y'all going to have to do that on the test tomorrow. Play the matching game. All right, let's get to some easy stuff. Volume, home stretch here, easy stuff. All right, find the volume of the composite figure. Composite, that means I got two things, two different shapes. I'm going to break this box down into purple, and guess what color I'm going to use? You guessed it, orange, purple and orange. Okay, finding the volume of the orange box is easy. I'll just say volume of orange prism. That's easy. I have all three dimensions. Okay, volume is equal to length times width times height. I have the height, that's the 8. I have the width, which is the, or length, we'll call that length, the 4, and I have the width. This width is 2. That's going to be the same width as this guy down here. So that's just going to be 2, that's just going to be 8 times 4 times 2. 32 times 2, that's 64 feet cubed. Okay, that's easy because I already know all three dimensions. Now for the purple one, it's not so easy. I do have the height. I got that guy. That's the 3. So I'll say volume of purple prism is also length times width times height. So I got the height. I also have the width. I got the 3 and the 2. 3 times 2 times... Okay, but what is this length here? I'm missing this dimension. Well, I've got to look at the other lengths. I've got a full 6 length here, and I've got a 4 here. So I just do 6 minus 4. That means this piece has to be 2. So it's 3 times 2 times another 2. 6 times 2 is 12. Okay, so my total volume, I'm going to add those two numbers together. 64 plus 12, and that equals 76 cubic feet. Okay, number 20. These last four are super easy. It's just plug and chug into the formula. Formula for the volume of a cylinder is pi r squared h. Do I have the radius? Yes, I do. Do I have the height? Yes, I do. So that's going to be equal to pi times my radius squared times the height, which is 40. They don't say leave it in terms of pi, so I am typing in pi into my calculator. So it's just a second pi times 25 squared times 40. And that gives me 78,539.8. 78,539.8. And the units on that are inches, so it's inches cubed. Okay, cone, volume of a cone, and I will have these formulas for you guys on the test. 1/3 pi r squared h. It goes up to a point, so it's the same thing as a cylinder, it just goes up to a point. I would have to fill up a cone 3 times to pour it into the same cylinder with the same base and the same height. That's why it's 1/3. Do I have the radius? No, I don't. I have the diameter. The diameter is 8, so the radius is 4. Make sure you guys pay attention to that on the test where they give you diameter or radius. So that's just going to be 1/3 times pi times the radius, which is 4, squared. Don't forget to square it. Times the height, which is 12. So on my calculator, I will press 1 divided by 3 times second pi times 4 squared times 12. And that gives me 201.1. 201. 0.06. Let's just round to the nearest tenth is fine. 201.1, and that is also inches cubed. Okay, pyramid, super easy. Volume of a pyramid is equal to 1/3 times length times width times height. Did they give us a slant height here? No, they were nice to us. We don't have to use Pythagorean theorem. I have the height that I need. So that's just 1/3 times 6 times 7 times 8. Can't get much easier than that. Just multiply all three dimensions together. If it were a square base, sometimes they'll say it's a square base and they only give you one side, and you just say if it's a square base, then the other side also has to be the same dimension there. Same length. Alright, so let's go 1 divided by 3 times 6 times 7 times 8. I get 112. Units are, they like inches. Inches cubed again. Sphere, last one. Volume of a sphere is 4/3. We got that wacky 4/3, and it's radius cubed. Radius cubed. Do I have the radius? Yes, I do. So it's plug and chug. That's what we used to say in college. Plug and chug. Plug into the formula. 9 raised to the 3rd. Don't forget to cube this. That's the only one that's not squared with a circular base or any kind of pi in it. So it's going to be 4 divided by 3 times second pi times 9 raised to the 3rd power. And I get 3053.6. Alright, and that's going to be centimeters cubed. Hope you guys enjoyed this video. I wish you best of luck on the test, and we will see you on the next video.